Okay, so today we are going to start with electrical energy and electrical power. And in electrical energy or in the concept of electrical power, first of all, we know about electrical energy. Electrical energy can be defined as, if you remember, we already discussed in the idea of potential difference and EMF, the energy or the energy converted per unit charge. So by using that idea, V is equals to energy over charge. So energy will be equals to voltage into the charge. So you can write down the formula for electrical energy or the equation for electrical energy like this: E is equals to VQ. Or let's suppose if we substitute the value of Q, because from the formula of electric current I is equals to Q over T, we know that Q is equals to IT. So this formula can be written like V into IT. So electrical energy is equals to VIT. Okay. And when we talk about electrical power, so the basic formula of electrical power or like any type of power, so power can be defined as energy per unit, or the rate of doing work is called power. So basically energy over time, work done over time is called power. So P is equals to electrical energy over time, and electrical energy is equals to,
VI.
yes, VIT over T. So finally power is equals to VI. And let's suppose if we use the concept of the Ohm's law to just find out the concept of the resistance, because sometimes in the circuit they ask you to find out the power dissipation, like the power which actually waste in the form of resistance in your circuit. So for that scenario, so the first possibility is if we use the formula P is equals to VI, and if we substitute the value of V with the Ohm's law, V is equals to IR. So P is equals to I square R. And the second possibility is if we substitute the value of I, so I will be equals to V over R according to Ohm's law. So P is equals to V square over R. So this is the concept of electrical energy and the electrical power that helps you to find out electrical energy by using formula and electrical power or electrical energy in your questions also. And after this, if we continue with some questions related to the electrical circuit, like the combination of the resistance, electrical power, electric current, potential difference. So let's suppose this is the first question. In this question, a 12-volt battery is connected in the circuit containing resistors A, B, C, and D. So there are four resistors and each resistor is of 6 ohms. So first of all, you have to calculate the combined resistance. So
12 ohms.
12 ohms, okay. And all of you try by yourself also. The value of each resistor is 6 ohms. So according to the combination of the resistance, you have to find out by yourself, because previously we discussed all the resistors either are connected in series or either they are connected in parallel. But in this question, there is a mixture of combination, like there is series combination and parallel combination also given in the same diagram. So that's how you have to find out the combined resistance. So basically, there is very simple technique to find out the total resistance in this type of question. First of all, try to join two resistors one by one, right? If you try to solve all the resistor at a single time, so it will be difficult. So you have to, like, if we join these two resistors, so these two are connected in series combination. So you have to apply the formula of series combination. So it will become a single resistance 6 plus 6 of 12 ohm.
I thought we multiply, but no, we add. Okay.
No, you don't need to multiply. You have to use the concept of series or parallel combination. So first of all, we just combine these two resistors and they are joined in series combination. So your new circuit diagram will be like this. Okay. And after this, we know that what is the combination of these two?
Parallel.
Yes. So they are joined in parallel combination. So we have to apply the formula of parallel on these two resistors.
It's 4 ohms.
Okay. So if you flip the value, so definitely you will get answer 4 ohms. So finally, actually we join A, B, C. So this resistor is joint resistor of A, B, C, and the total value is ohms. And finally, we have to join with option D or resistor D.
10 ohms.
10 ohms. We are getting,
Yeah, 10 ohms.
okay, so we are getting 10 ohms as the final answer of the overall combination, right? And in the first part, they are only asking about A and B. So as we join them, A and B, so we will get answer 12. Okay. And then we join ABC. In ABC, we got 4 ohms. Because in this question, they mention like step by step. But not every time you will get question like this. Sometimes they ask like just find out the total resistance. Okay. So then you have to choose resistors by yourself, combination by yourself. So that's why we just solve by ourselves without looking the questions. In second part, we got 4 ohms. And when we join A, B, C, D, so that will be equals to A, B, C, D, 10 ohms. This will be equals to ohms, right? So it depends upon the question. Sometimes they will ask like for 3 marks or 2 marks or 4-mark question. Circuit is given and you have to find out the total resistance from the circuit. Okay, in part B, we have to calculate the current in the battery. Okay, so we have to find out the value of I. And if we take the reference of the diagram, so voltage is given
1.2 amperes.
1.2 amperes. Okay, so basically in this concept, what we have to do, we have to use the formula of Ohm's law. V is equals to IR, because you know current is unknown, voltage is given, and resistance and the value of resistance is already given. So we will use the value of 10 ohms because this is the total resistance. And in second part, the energy transferred from the battery to the circuit in 50 seconds. So time is 50 seconds and you have to calculate the energy transfer, and the formula of energy is E is equals to VIT. So we already know about the value of voltage, electric current, and the value of time is given. So by multiplying all the values, we will get the answer of energy, right? 12 into 1.2 into 50, 720. So this is like a basic practice question for the combination of resistance and energy and electric current.
Oh yeah, sir, this question came in my exam.
Okay. Okay. Basically there is a concept of fuse in this question. Fuse is like a safety component, and you can see fuse is connected with the positive terminal or from where the current starts to flow. So fuse is always connected with the live wire from where the current is moving on, because if the value of current or the voltage exceeds, so the fuse will just melt or blown off. Because of this, no current will flow throughout the circuit. So basically there is a concept of fuse also. Fuse is like safety component. It helps you to protect your circuit. So if we talk about the fuse, so fuse in simple words is used for the safety precaution. So this component helps you to protect the circuit, and it is also a safety component in your circuit. It is a safety device designed to cut off the flow of electricity to an appliance. If the current becomes too large, and this will normally happens in our homes or offices sometimes, that sometimes the value of the current will increase due to fluctuation or due to any problem in the main power supply. So basically fuse will help us to protect us from the short circuit or any damage to the appliance. So we use this fuse in the main line or in the main circuit. So when electric current starts to pass through the fuse, and if the value of current starts to decrease as compared to the normal value of the electric current according to the fuse, so definitely it will cut off your electricity supply to the components. So your components will be safe in the case of any fluctuation or any increase in electric current value in your circuit. And this is the electrical symbol for the fuse. You just need to make like a resistor, but the line is passing from the center. In resistors you can see line will not pass from the center, but in fuse line will pass from the center. So this is the difference between the fuse diagram and the resistance diagram. So they are almost like the same, only there is a difference of line passing from the center. And if we talk about the components of the fuse, like how fuse is made or what are the components from which the fuse is actually made. So basically there is a glass type cylinder material, and in the center there is a very thin wire. So it consists of a glass cylinder which contains a thin metal wire. Okay. And when the value of electric current becomes too large, so what happens with the fuse? When the value of electric current becomes too large, so wire heats up and it will melt. And when it will melt, so definitely there will be like a gap in a circuit, so circuit will be incompleted over there. So this causes the wire to break, and it will help us in breaking the circuit. And is stopping the current. Okay. So basically this is the idea of the fuse, how fuse works. And there are different varieties of the fuse. Variety in the sense, like there are different values of the fuse, like normally that we use in our circuit is 3 ampere, 5 ampere, 13 ampere. So basically, you know, if your circuit is working on like 4 ampere, 4.5 ampere, or like this value, uh, before like 5 ampere, under the value of 5 ampere, so we use the fuse of 5 ampere, because the requirement of the circuit is like 4.5 or any value before 5 ampere. So we use the fuse of 5 ampere, because if the value starts to exceed, or if the value of electric current reaches 5 ampere, so after 5 ampere the wire becomes heat up and it starts to melt, and definitely it will break the circuit and no current will flow throughout the circuit. So in this way we use different value of the fuse in our circuit according to the situation, or according to the condition of the electrical circuit, that what is your requirement of the current and how much current we allow to flow in the circuit. Okay. So basically you can see there is also a 13 ampere. 13 ampere means like if we are using 10, 11 ampere value of electric current in the circuit, so then we use this 13 ampere, because if the value exceed from 10 or 11 or 12 ampere, so definitely it starts to heat up and finally it will melt and blue, because of the value of electric current exceeds in the circuit, right? So in this question you can see there is a concept of fuse. Three lamps are connected and a fuse is also connected to a power supply, and the EMF of the supply is 220 volt. Each lamp is labeled 220 volt and 40 watt in power, and the rating of the fuse is 2 ampere. You have to calculate the current in each lamp. So how to find out the current in each lamp? Basically it is mentioned that each lamp is labeled with 220 volt. It means the voltage for each lamp is 220, and we know they are connected in parallel combination, so definitely their value of electric current will be variable, not the same. So according to the formula of power, P is equals to VI. So power is 40 watt, voltage is 220, and the value of electric current is unknown. Zero 0.18 ampere, right? Okay. In the second part, they are asking about the current in the fuse. So first we calculate the current in each lamp. Now they are asking about the current in, because you can see when current starts to flow, so definitely it will pass through the fuse first, then from the other components. So what we have to do for this, any idea how to find out the current through the fuse? Okay, in this question, remember one thing, when we find out the current through each lamp, so important thing is these all lamps are connected in parallel combination, and we know that in parallel combination electric current will be divided into the components. It will not remain same, just like the voltage. So in parallel combination we have to find out like this. So if we join them, so we will get the total value of electric current. So this is the concept that we studied in the resistance also over here, that in parallel combination electric current will be divided. So we have to find out by adding all the values of electric current. So this is the hint for your second part of the question, that you have to just add up all the values of electric current or just multiply the value of current by 3, because there are 3 lamps, and it means the value of electric current passing through the fuse, total value of current, and after passing through the lamp it will divide like this. So basically
0.54.
yes, because in
Wait,
this
how is
question,
it 0.54? Is it because like you're adding? Okay, yeah, you're right.
basically the reason behind this part is question is for 1 mark, but there is very like deep logic behind it, because all lamps are in parallel, and in parallel current divides individually according to their strength of voltage and power, whatever we are writing about. But for this question the value for the voltage of each lamp is same. Otherwise we will find like I1 individual, I2 individual, I3 individual. So we calculated this value of electric current, so this is for each lamp. So each lamp consists of 0.18 amperes, same over here, same over here. So in parallel combination we have to join all the values of electric current to get the final total current. So definitely from the fuse is a single component, so definitely the total value of electric current is passing through the fuse. And the next question is the total number of lamps all in parallel that could be connected without blowing the fuse. So basically they are asking the question, you have to find out the total number of lamps, that how many lamps we can connect in parallel in the same circuit without blowing up the fuse, because you know the value of fuse is 2 ampere, the rating of the lamp is 2 ampere. So the rating of the lamp is 2 ampere, and we are getting like 0.18 ampere from each lamp. So how many lamps we can connect?
11.11.
11.11. Okay. So basically the total value of the ampere that fuse can bear is equals to 2 ampere, and the electric current produced, or the electric current passing through each lamp is 0.18. So let's suppose if we want to increase the number of, we have to do, we can just simply ampere by 0.1 ampere. So it will help you to find out that how many lamps you can connect in a circuit under this value of 2 ampere. So 11.11 is the number. So it means we are able to connect between 10 or 11 lamps in the circuit, right? So this is like a,
If it said with blowing the fuse, anything above 11 would be correct, right?
yes, because in this question there is no idea of resistance is given, right? We know resistance always present, so that's why uh, it will be like less than 11, because due to resistance it already heats up, so definitely it will be less than 11, but according to the calculation it will be equals to 11 lamps, right?
Okay, sir, thank
So it means you can connect 11 lamps in your whole circuit, same like in parallel combination, and your fuse will not blow up because your value of electric current is under the rating of the value of the fuse. Okay. After a very long period of use, the wire filament of one of the lamp becomes thinner. So underline the effect of this change on the resistance of the filament.
Resistance increases.
Resistance increases, okay.
Resistance decreases.
Resistance decreases, okay. Okay, basically, thinner means cross-sectional area decreases, right? If you remember the formula, okay, I think we just note down in different file. So basically the formula, if you remember, is equals to, and thinner means the cross-sectional area decreases. So when cross-sectional area decreases, so definitely resistance will increase, right? So in this scenario, we can say resistance increases, right?
Now I see what I did wrong. I accidentally flipped it.
Yes. So this is the concept. And even if the length increases, so then also the resistance will increase, because definitely after some time wire becomes more heat up, or like the example of the charger, when we are using charger, so after some time your charger automatically starts to heat up as compared to the initial state, because it starts to resist more charges, so definitely it will more heat up. And finally state and explain the effect of this change on the power of the lamp. So resistance actually increases. So what is the effect of this concept
Power also increases
on
because the
power?
voltage increases.
Okay.
Yes.
And
Sir, wouldn't it reduce power?
okay, so you mentioned that power decreases, and few of you said that power increases. So basically, for the formula of power, power is equals to like VI, the basic formula. But if we talk about the resistance also, so we know that current actually decreases, right? Because when resistance starts to increase, so definitely current in the lamp also decreases, right? So when the
Oh, yeah, my bad.
yes,
My bad. Oops.
so according to the resistance increase in the circuit, current will decrease, so definitely your power will also decrease, because there is no resistor connected in your whole circuit, so we can only just relate with the reference of resistance and electric current. Because the current decreases. Okay, and according to your logic, for voltage, that is also fine, but in that formula we know that resistance is changing, so resistance changes, it means power decreases, right? So according to the concept of the power formula with the reference of voltage and resistance, so in that case also the value of power will also decreases, right? In this question we have one more component which is called a variable resistor rheostat, that helps you to change the value of electric current. Okay, let's suppose if we continue with question number 5 first. A student determines the resistance of a length of aluminium wire. So she connects the live wire in series with a battery and variable resistor. Variable resistor is just like there is a knob and you can change the value of resistance by yourself. It is not fixed. And she knows that an ammeter and a voltmeter are needed in the circuit. On figure 8.1, draw the circuit symbol for an ammeter connected in a suitable position. So where we have to fix ammeter in the circuit, we know that ammeter always connects in series combination. So in series combination, it means it will be connected over here in series combination. And when they ask about voltmeter, so definitely voltmeter should be connect in parallel combination. And in the second part, a variable resistor is included so that the current in the circuit may change, because when the resistance changes, so definitely the value of current changes. So suggest an advantage of being able to change the current. So what is the advantage of using different value of electric current? Okay, basically there is no like very specific related reason like with current voltage or like this. If you have different values of electric current and if you can change the value of resistance, so definitely you will get different values of electric current. And when you get different values of electric current, so definitely it will help you to like plot a graph with the reference of resistance and electric current with different values of resistance and different values of electric current. And it will also help you to just control the temperature of the wire, because when you feel the temperature is increasing, so you just reduce the resistance, so the heating effect of the aluminium wire will automatically decreases. And in B part, electricity is transmitted from a power station to a distant city using a aluminium cable of resistance 1.2 ohms. So resistance is given. Power loss occurs because of the resistance of the cable, and the current in the cable is 250 ampere. So what is the power loss in the cable?
75 kilowatts
Okay,
or 75,000 watts.
so right, resistance is given, electric current is given, and no other value is given in your whole question. So we know that if we use the basic formula, P is equals to VI, so voltage is not given, so we have to use the formula that includes electric current and resistance. Like here we discuss P is equals to I square R. Or if you just don't remember the exact formula, so you can also do like P is equals to VI and then use the concept of V is equals to IR within the question, right? So it is not compulsory to just mention the direct formula. So you can write like 5,000 watt, or you can also write, as you mentioned, 75 kilowatt, because kilo is equals to the thousand value.